Yeah, so Swasti, are we good to start now?
Yeah, Prathamesh will just quickly
Let me
introduce you.
Hello, hello everyone. Today we are having a professor, Ashwin Guha sir. Is a freelancer math educator, and he loves to explore mathematics about the various fields. And he he's a PhD in computer science from ISC Bangalore, and also was a part of the RAM TP 2025. There I was also a student under him, and that's where we're going to learn. And as we all know, the two, there are today's title of the lecture, and he also wrote the book of homework, which is a very popular book among all over the childrens and all over the math lovers. And let them start.
Okay, yeah. We're good to start now?
Yeah, sure, sir.
Right. Yeah, hello everyone. My name is Ashwin. So I'm a maths teacher. I can see some familiar faces here. So some of you have probably attended my sessions earlier, and yeah, some of the students are Asma, for example. I met them yesterday also. So yeah, it's good to be back as part of Roots Camp. I've been taking sessions in the Roots Camp, I think, for the last 2-3 years now. Okay, so today we're going to start the session on games of chance. So I think I'll be having 2 sessions with you. So today we'll have the first session, and I'll have another session with you tomorrow. Yeah, let me share the screen. Yeah, right. So Prathamesh and Swasti, in case there is some there is some technical glitch or something, you just let me know so that I'll be able to address it right away. So yeah, I think everyone can see the screen now. It's fine. Yeah, right. So yeah, welcome to the first session on games of chance. So what we'll be doing today is I'll just give you like a quick 5-minute history of games of chance. And then we will play some dice games. And I would like to share a particular problem, which was kind of one of the key problems of probability, and which was really like the beginning of probability as a field of its own. So I would like to share that problem with you today. And yeah, maybe tomorrow we will play some card games and analyze card games and so on. Right. So everyone who's attended my sessions before know that I have this routine that I do at the beginning of every session. So I give a few fundamental rights to the students. And of course, I would like to explain the ground rules for the session. Most of you, I think you might have attended a RAM session before. So, I mean, you must be comfortable with it, but I would like to go through this anyway. So, the first right that you all have here in this session, at least, is the right to be wrong. So, all of you might have different levels of exposure to the topic. So some of you might be very familiar with it. Some of you might be looking at all of these topics for the first time. So don't worry about not knowing things. You have come here to learn. So don't be afraid of giving wrong answers. Here it's perfectly okay. As I keep saying all the time, math class is the best place to make mistake because nobody's going to get hurt. Right. So don't be afraid to share your answers. It's okay for you to give the wrong answer. Don't just make the same mistake twice. That's all. And of course, you have the right to be different. So again, all of you will have like different background knowledge, right? So some of your friends might already know, uh, or you might have an answer which is different from your friends, or you might have a method which is different. So you have the right to be different. Okay, don't worry about what your friends are doing, how they are solving the problem. And of course, this is not a competition, this is not a test, this is not a race. So we have a limited amount of time, but let's try to make the best use of that time. And don't worry about what your friends are doing over here. And of course, you have the right to question. So right to question means, number one, if you don't understand something during the session, you can always like raise your hand and interrupt. I'll try to address your question as much as possible. Second part of the right to question means you don't have to accept everything that I'm saying just because I'm saying that or just on authority, right? So you have the right to disagree with me. So if you do not agree with something or if you object to something that I'm saying, you of course have the right to question me and I'll try my best to clarify whatever I'm saying. So these rights are applicable to everyone all the time. And these rights are applicable to me also. So I might also make a mistake sometime in between, or I might introduce a concept in a way different from what you have heard. And of course, I have the right to question you guys. We will have a few ground rules. So yeah, please be on time so that we make the best use of the time that we have in Bootcamp. In case you need to get my attention, use the raise hand feature on Zoom. Because I'll be sharing slides, I'll be looking at something else. I might not be able to see the screen. And if you just raise your hand on video, I might not be able to like see who's responding. Because we have many participants here today. If you just start speaking, I will not know who is talking to me. And even if you just quickly introduce myself, I might be distracted by something else. So I might not be able to like understand who is asking the question. So just raise your hand and just be a little patient. I'll try to address your concern during the session. So one other convention that I have is, if you have a doubt or a question, use the raise hand feature, the open palm feature. If you want to convey that you have the answer to a question or you have finished an activity, just give me a thumbs up. So if I see a raise hand, I'll assume that you have a question or you have a doubt that you have to clear. If I see a thumbs up, I'll understand that, okay, you've finished the task and you're ready for the next task, right? Yeah, please stay on mute because there are many of us here. Yeah, it's important that we maintain a good atmosphere for all of us. So just stay on mute. In case you need to speak, when I ask you to speak, you can unmute and speak. And yeah, now these were just like basically kind of decorum rules. So now is the first mathematical or academic kind of rule. So here we will be having a lot of back and forth. So it's not that I'll be giving you a lecture for the next 1 hour or so, but we'll be having a discussion. You are free to object to a claim that I make. Your friends also will be making some claims. You have a right to object to them. But nobody here should make a claim without a justification. So you can't just make a claim without giving a reason or a proof to back it. Sometimes you might have like a hunch, maybe it's a guess, or you have a hunch, but you are not quite sure. In that case, you have to make it clear that this is not a proof, this is just your guess. So no claim without a reason. And these days, especially in the online session, no help from the internet. So of course, we are using the internet to make this session happen. We are like having the session over Zoom. But now you also have like so many tools right at your fingertips, at your disposal, right? You have AI tools, you have Google, you have this and that. But please don't use those tools during the session, during the next 1 hour or 1.5 hours. I'm saying this because uh, it would be good if you explore the concepts or all the activities on your own first. And after that, you can like look up and read about the topics and so on. So in fact, I would want you to read about whatever topics we're discussing today, but don't get distracted and don't do it during the session. So no chat GPT, no AI tools, no searching for Google. Yeah, no external help from outside of this classroom, right? So these are the ground rules and yeah, these are the rules for today's session as well as tomorrow's session. So now let's go on to the yeah, the topic at hand. So before I go to the topic, I wanted to give a kind of a warm-up puzzle for you guys. So now imagine that there is a chemical X, there is some substance X, and these are like all the properties, or these are like the properties or effects of that substance. So this substance is like widely available in our society. It's like used by many people. It's very freely available, and it causes many deaths every year. And it is a chemical that people use, but when it's used in an impure form, it actually causes a lot of diseases, some of which are even like life-threatening or like even deadly, right? So this chemical, it's also found in like the gaseous form, and in its gaseous form, it will disrupt weather patterns and yeah, like even the climate at like a global level. And this is a chemical that all criminals use before they commit a crime. So at least 24 hours before they commit a crime, all criminals have admitted to using this substance. So now there is a chemical like this, which is there all around us. Now the question is, should we ban this chemical? So I would just like to take a quick poll over here. So those who think we should ban this chemical, give a thumbs up. Those who think we should not ban this chemical, give me a thumbs down. So yeah, we have this chemical with all these properties. Those who think we should ban it, just give me a thumbs up. Okay, I can see. Yeah, I mean, I can see that 6 people have given their thumbs up. Others, are you like not decided, or you think it should not be banned, that we should have this chemical only, this chemical which has all these effects? So yeah, Anantajit, why would you like to ban this chemical?
Well, sir, even if it has some good use, sir, we can see all the negative effects which it gives, and so well, it's dangerous and like it's a threat. So
Okay,
that's
right.
why.
Okay, so yeah, you're saying even if it has some benefits or some beneficial uses, because it's having all of these so many different negative effects, we should ban this. Okay. Is there anyone? Uh, yeah, nobody says we should not ban. Okay. So now, yeah, Shivansh, do you have something to say?
Yeah, so like even water satisfies all these conditions. So we can't say if we should or should not ban just on this much information.
Correct. Yes, Shivansh. So if you take water, water is the substance that I'm talking about, and that satisfies all these properties, all these features and effects, right? It's widely available and it causes many deaths in flooding, even by drinking polluted water. And of course, yeah, polluted water causes a lot of diseases, and the water vapor in the atmosphere decides our weather patterns. It makes it rain, it makes drought, and it also like defines the climate of a place. And all criminals drink water every day. All non-criminals also drink water every day. In fact, we are all recommended to drink a lot of water, right? So this substance X is nothing but water, and you can't ban this water without which there is no life. So yeah, basically this is a kind of a trick question where I only give you selectively available data, and if you are going to make a judgment, you also need to gather other data which is probably like not available to you, right? So yeah, I can see Nandika, you have raised your hand. Do you have something to share?
Yes, how can water be a chemical?
It is also a chemical. Chemical is anything that is made up of matter, and water is also a chemical. So chemical does not mean it is artificially produced. Right. Okay. So now I hope you can see that you need to ask for questions, ask for more information, which you probably are not given initially, right? Look at the history of games of chance. So in Indian history, that is even India with its very diverse culture and diverse traditions, all of India has been playing different games of chance. In fact, Mahabharata, one of the most important scenes in Mahabharata is the game of dice that Yudhishthira plays, and he loses to Duryodhana. And yeah, a lot of important things in Mahabharata happened because of a game of chance. And even within Mahabharata, there's another story of Nala Damayanti, where Nala is this king, and he marries this princess Damayanti, and Nala also he gets into gambling. He like plays a game of dice with his brother, and he loses everything. He loses his kingdom. He loses his wife. Later, he even loses his memory. Right. So in Indian folklore, there is a lot of reference to games of chance, games of dice, but it's been kind of given a very negative connotation. That is, games of chance usually refers to like a game like Ludo or something with dice, and it has been compared to gambling, and it has been like described as a vice. It's like a bad habit that you should not indulge in. But of course, many of us would have played games like Snakes and Ladders, which is an Indian origin game. So Snakes and Ladders, of course, we will have played for entertainment because it's fun. But in like maybe the traditional India, Snakes and Ladders was not just a game for entertainment, it was also used to teach morals. So uh, all the ladders would correspond to like good habits or good character or like noble qualities. And all the snakes correspond to bad habits or evil qualities or something like that. So it was really used as a kind of a tool for moral science. Uh, so all cultures around the world, they have been playing different games of chance. What we are more familiar with is with dice. Of course, in ancient India, people used other things also. For example, they used these cowrie shells, right? That was used instead of the six-sided cube that we use as dice today, right? And in Mahabharata, for example, they used to roll some kind of a cuboidal dice and so on. So yeah, basically people around the world have studied the different games of chance. In around 1500s, like in 1550s or something like that, 500 years ago, there was this mathematician named Gerolamo Cardano. He wrote a book called Books on Games of Chance. So this was like the first, you could say, textbook on games of chance. Of course, people have been playing these games for thousands of years, but Cardano was the first guy to kind of like put it into a mathematical form and made like a book out of it. After Cardano, there came these famous mathematicians, Pascal and Fermat. So Fermat, you might have heard his name associated with Fermat's last theorem, Fermat's little theorem, and so on. And of course, Pascal, he was a mathematician and he was also a scientist. So you might have heard of Pascal's law in physics and so on. In fact, the SI unit for pressure is Pascal, right? So Pascal and Fermat, they lived in 1600s, so about 400 years ago, and they were actually discussing a game of chance, or they were discussing something to do with a game, and their discussion actually led to what we call probability today. So basically, what start field of maths, it owes its origin to different games of chance. And in particular, the more formal or textbook kind of way of learning probability, it came from Pascal and Fermat. In today's session, I hope to introduce that problem, which kind of led to the discovery of probability, you could say. Right. So games of chance, of course, it is really a kind of cover for me to talk about probability. I think many of you will be in grade 7 or grade 8. You might have had like a very preliminary introduction to probability in your school from your textbook. But some of you might have had a little more exposure to probability, I assume. So today I'm not going to have any, I'm not going to make any assumptions on what you know about probability. It's good if you have some idea about probability. It might help you in today's activities, but yeah, it's not essential. So probability is nothing but a way to quantify uncertainty. So when we think of probability, we immediately jump to the dice games or tossing a coin or something like that. But probability is something that we use every day. Like, for example, you want to guess whether it's going to rain today or not. If it rains, if you think it might rain, you want to take an umbrella, right? So it is something that we use all the time. And probability, it is not just for gamblers, but even other kinds of professions need probability. For example, doctors need probability to assess whether someone has a disease or not. So, like if a patient comes with a symptom, if a patient says, I have headache, fever, and so on, it could be because of so many other things. It could be because the serious illness or it's just a normal fever and so on, right? So even a doctor needs to know how to use probability. Similarly, uh, like if you're an engineer, you might have like different components working together in a machine, right? And if each component has a separate failure rate, that is, you have a failure rate of say 1% or 0.1%. You want to assess how reliable this machine is, right? So probability is used by many different kinds of people, but for us, we will just look at probability as beginners without any specific application in mind. We will just see how it connects to different games of chance. So think of probability as a way to quantify your surprise or unsurprise level. So for example, it's like if you toss a coin, you will get either a head or a tail, and you think both head and tail are equally likely. We are assuming the coin is unbiased, so you think it's equally likely, right? So now, if I said, if I had a dog in my house, right? It might surprise you a little bit. Yeah, I mean, you might not see the dog here, but you would be a little surprised if you found out that I have a dog in my house. So it is not very likely, but you shouldn't be surprised if it happened. But suppose in my house I had an elephant. Now that would be like really surprising, right? I mean, having an elephant is not physically impossible. Maybe somehow I cram an elephant in my house behind me, but it would be like very surprising. So probability is a way of quantifying this uncertainty or element of surprise. But instead of just saying I'm very surprised or not at all surprised, we will do it in a little more mathematical way. So that's what probability is about. So now if you ask a question, is India going to win the World Cup or something like that? So you might think that it is very likely or unlikely or something like that. Now, if I have two events, that is, who is more likely to win the World Cup, India or Bangladesh, right? So now, even if you don't have a number, even if you don't have like proper quantity to describe the probability, you can at least say which is more likely or which is less likely. So yeah, if you are having a cricket match between, say, India and Australia, who is going to win? Yeah, I mean, you shouldn't be surprised if India wins. You shouldn't be surprised if Australia wins either. But if it's like a match between two unequal teams, like say Ireland and South Africa, you would think South Africa is more likely to win. Of course, it doesn't mean that South Africa will always win. It's not a guarantee. It is just that it looks like South Africa is like a stronger team, so it might beat Ireland. That is what you would think. So now once you are attaching numbers to these probability, you can compare numbers, which is more likely, which is less likely, and the question of how many times more likely. One thing that many of us initially, our intuition for probability is thinking like, if I do it many times, how many times will I get this outcome or that outcome? Like, if I toss a coin 100 times, you are probably thinking, okay, I'll get 50 heads and 50 tails. But that would not be a good way to think of probability, because when you study higher levels of probability, this question becomes a little tricky. So don't think of it as, if I toss a coin 1,000 times, I'll get 500 heads and 500 tails. Just think of it as, I'll be as surprised getting a head. So head and tail, whatever surprise that I have, it is equal. So it's like I'm equally unsurprised if I get a head or a tail, right? So that's why you are assigning a probability of half for both of them. Okay, so now this was just really a kind of build up to the actual activity we're going to do. Okay, so today we're going to play a game with dice. So this is the game. I will roll a pair of dice and you need to choose a number, right? If the total of the two dice, it turns out to be your number, you will win a prize. Okay, so this is the game. We will just play this game for fun for like 2 minutes before I go on to like the next question. Right. So yeah, I need to share a different screen. So just give me a second. Okay, right. So here it is like, I'm just going to roll a pair of dice. You can just play on your own just by like guessing a number, and if you get that number, you win that prize, right? So everyone, just write down a number for every round. We will play for like say maybe 10 rounds. Okay. So the beginning of every round, just write a number. If you get that number, you win that round. Okay. So let me just get to the dice. Okay, right. Okay, so now just write down the number. If you get that total, yeah, you just win that round. You don't have to share your answer right away. You just make a note of what was your total and what was the total that we got. Okay, so yeah, round number 1, just write down your total. Okay, so now I'm going to roll the dice. Okay, so here it comes out to be 8. So yeah, if you initially chose 8 and now you got 8, yeah, you win this round. So now round 2, just write another total that you want to bet on. I'm just going to give you like 5 seconds for this. Okay, round 2. 6. Okay, now write down your number for round 3. Okay, third round is again 8. Okay, so now pick a number for round 4. Okay, here comes round 4 is 11. Okay, pick a number for round 5. Yeah, because there are many of us, I'm not like giving too much time. I expect you to like do this quickly. So yeah, round 5, choose your number. Yeah, hope it's ready. Now for round 5. It's again 8. Okay. Round 6, choose your number quickly. Okay, here comes round 6. It's 2. Okay. Choose a number for round 7. Okay, here comes round 7. 5. Okay. Yeah, there's actually a tablet tool here, but yeah, I want all of you to keep track of the numbers, so that's why I'm not enabling that function. So we have 7 rounds done. Choose a number for round 8. Okay, here comes round 8. And it is a 7. Okay. Choose a number for round 9. Okay, so yeah, round 9, the total is 9. Okay, choose a number for round 10. We are just going to play 3 more rounds so that we have like 12 trials for this. So choose a number for round 10. Okay, here comes round 10. Huh. Again, round 10 is the total is 10. Okay, choose a number for round 11. Okay, let's go for round 11. Okay, the total is 5. Okay, now the last trial. So choose a number for round 12. Okay, here comes the last round, round 12. It is 6. Okay, so right. So we have we played this game for 12 rounds, and yeah, I got different totals. So now I just want to know how many rounds you guys won. So Prathamesh, is there a way I can run a poll right now?
Did you call me, sir?
Can I run a poll now?
Yeah, sure.
How should I run the poll here?
I can create one, I think. Can you tell me what you want the question and options to be?
Okay, fine. I think I'll just do it here with the group
Oh,
because
yeah,
it
okay.
can be extra cumbersome. Okay, so how many of you won 10 or more rounds here in this game? We played the game for 12 rounds. How many of you won 10? Okay, Nandika, Bhargav, Verma. Okay, 10 rounds. Okay. Okay, how many of you won 6 to 9 rounds? 6, 7, 8 or 9. How many of you basically got the number correctly for 6 to 9 rounds? Okay. How many of you got for 3 to 5 rounds? So Arav 3 to 5, Ankit 3 to 5. Okay. Lot of guys for 3 to 5. Okay. How many of you got 2 or less? Okay, right. So many of you have got between 3 to 5, and equally many, I would say, yeah, many of you have got between less than or equal to 2. 3 to 5, a lot of them. 6 to 9, a few. No, 6 to 9 people, which looks a little suspicious now. Okay, so now let me go back to the slides. So we played this game, which is a random game. I mean, the total, we will assume that the computer dice was random. First of all, what are all the possible numbers that you can get as the total? You can send your answer in chat. Send it. Yeah, okay. Just send it, post it in chat. What is the possible totals that you can get? Yeah. So many of you are able to answer this quite easily. The possible totals are from 2 to 12. So you're rolling 2 dice. The dice is, I mean, it's the normal dice from 1 to 6. So the total can be minimum 2, maximum 12. So now if you had to choose a number, and if that total shows up, you will win the prize. So which number would you choose? Put your answer in chat. So which number would you choose if you are going to play this game? Okay, I just give like a few seconds extra for everyone to type their answer. Okay, right. So, Malol, you said 8. You said you will choose 8. So, why did you choose 8?
No, sorry. Not 866. I changed my thought.
Okay, right. So, yeah, I mean, I'm having many answers. So, maybe I'll choose Deepika. So, Deepika, why would you choose the number 8?
Probably because there was more probability of coming 8 when you roll the dice. There were like more of 8.
Oh, right. So when we played this game, we got 8 many times. We got 8 3 times. So you think it is more likely to come, right?
Yeah.
Okay, right. Yeah, that's a reasonable explanation. So yeah, I hope I'm still sharing the screen. Is the start. Right. So Naisha, you have chosen 7. Why did you choose 7?
Sir, because once again there's a more probability of 7 because of the sum of the dice.
Can you explain a little bit more?
Like 7 is an odd number, and many times also we got 7 during the game that we played.
No, we got actually 7 only once.
Yes, sir.
Okay, so right. Okay, at least here, when I went through the chat, many of you have chosen like the numbers between 6 and 8. It's most of you have chosen like 6 or 7 or 8. A few of you have chosen like has chosen 9, but apart from that, most of you have chosen like only the 3 numbers basically 6, 7 or 8. So why did you have that preference? So like let me share. Uh, yeah, let me share the proper screen. Right. So You all chose the numbers 6 or 7 or 8 because you thought that was more likely to come. Okay. So now, suppose I ask you this question. That is, you choose a number, and if the total comes out to be that number, you win that prize. But now I am not going to give you the same prize. So it's like if you choose the number 2, and if you get 2, then I'll give you more. I'll give you more cash, because it looks like everyone is choosing 7. So it's like if 7 is very likely, then you will get 100 rupees. But if you get something that is more rare, I'll give you like bigger price, right? So now suppose for someone who bets on 7, and when they get 7, I give them a price of 100, right? So now, what should be the price for getting 11, and what should be the price for getting a 2? So first, let's look at this. So suppose the game is that it's like if the total comes to be your number, you will get a prize. But if you choose a very rare number, and if you get that rare number, you'll get a bigger prize. If it's a very common number, you will get like a smaller price. So for 7, I am giving 100 as the price. So what should be the price for 11? So I'm just going to give you a couple of minutes to think about it, and then we will of course have a discussion. So don't reveal the answer. Don't post the answer on chat, because I want everyone to think for a little bit. So just work on your own, on your notebook or somewhere. I'll just give you 2 minutes to think. After 2 minutes, we are going to have a discussion. Okay, so if you have an answer, just give me a thumbs up, and I'll point out to you, and then you can share your answer. So if you have an answer, give me a thumbs up. So Madhusudanan, can you share your answer? What's your answer?
Yes, sir. So for the odds of getting 7 there are 6 different ways in which you can get 7. The ways are the rolling dice 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. But the odds for getting 11 are only 2, which are 6 and 5 and 5 and 6. So as the prize money for getting 7 is rupees 100, the prize, so the as 6 divided by 2, which is 3, I multiply the prize money given for 100 into 3, and I'm giving rupees 300 as the prize money for getting 11.
Okay, nice. So yeah, that's right. That's how I would also approach the problem. So I'll just explain it once more for everyone. So we are now giving for a total of 7. The price is rupees 100, right? So now, how many different ways can you get a 7? You can get a 7 if you got a 1 and a 6, or a 2 and a 5, or a 3 and a 4. But we will also consider 4 and 3 as different. That is, 3 comma 4 means I got 3 in the first die, 4 in the second die. 4 comma 3 means 4 in the first die, 3 in the second die. So it's basically a different combination. So now I have 4 3, then 5 2, and 6 comma 1. So basically I have 6 different ways, 1 2 3 4 5 6, 6 different ways to get a total of 7, right? Of 11, the way I can get 11 is either I have to get a 5 and a 6, or I have to get a 6 and a 5. So that means 7 is 3 times more likely than 11, right? So now if I'm trying to be fair to all the participants, whatever price that I'm giving for 7, I must give 3 times that price for 11, because it's like 3 times rarer, right? So here, if my price for 7 is 100, because 11 occurs 3 times more rarely, or the probability of that occurring is 1/3 of 7, I should basically reward the person who bet on 11 even more. I should give them a higher reward. And I will just give them the reward proportional to the odds. So it's going to be 300. Right. Yeah. Does anyone have any doubt? If you have a doubt or if it's unclear, just raise your hand now. Oh, right. I hope everyone is comfortable with this. So now let me ask the next question. So what do you think should be the price for getting a 2? Don't share your answer immediately. Just take 2 minutes to work it out, and then you can share your answer. I'll tell you when you can share your answer. Okay, right. So if you would like to share your answer, just give me a thumbs up. So yeah, there are many of us here. I would like to give a chance to everyone, but yeah, because there are many of us, I can't give a chance to all of you. So yeah, please be patient. I would like to choose someone from whom I have not heard today. So yeah, Bhavadharani, would you like to share your answer?
Yes, sir.
Yeah, okay. So about that, there was a lot of background noise from your side. Maybe I'll ask someone else. So Kia, can you share your answer?
Yes, sir. It should be around 600 rupees. As if we compare 7, there are 6 ways to write 7. But if we want to write 2, there's only one way, which is 1 and 1.
Correct.
Both the dices will get 1. So it's like 6 times the 6 ways. So we should get 600 rupees for the price.
Wow. Nice. Right. So you can see that 2 is or 7 is 6 times more likely than 2. So yeah, you want to give the price of 6 times 100. Fine. So now let's play the game with 3 dice. But before that, I want to ask this question. So now, what do you think is the probability of getting a total greater than or equal to 10? First, would you say that the probability of getting a total greater than or equal to 10 is 3 by 11? So now I will say why it is 3 by 11. So let me go to the polypad. Yeah, right. Right. So yeah, in Zoom, it's like there are so many windows. It's really hard to keep track of what's going on here. Anyway, so now I want to see probability of the sum being greater than or equal to 10, right? So here is my logic. The total can be 2 or 3. Right. So these are all the possible totals that you can get. So among them, these are the totals which are greater than or equal to 10. So total possibilities is 11, of which our favorable outcomes is like the outcomes that we want to be greater than 10 is 3. So now I can say that probability of the total being greater than 10 is 3 by 11, right? So yeah, is it clear to everyone? How many of you are now think the total greater than 10 is 3 by 11? Yeah, Sanjeev, you have raised your hand. Do you have a question?
Yes, sir, I have a doubt.
Yeah.
Sir, in this case, you have counted the possibility of 10, 11, and 12 to be equal. But in cases of dice, it isn't because there are different ways to get 10, different ways to get 11, and different ways to get 12.
Yes, correct. Yeah, Sanjeev, you are right. So here, if I were to calculate the probability this way, saying that, yeah, of the 11 possibilities, 3 of them are favorable, so it's 3 by 11, that would not be the correct way to do it. That's because the same reason that we saw earlier. You can basically get 7 in many more ways than 11 or a 2, right? So that means your 7 is much more likely than a 2. So because of that, you cannot just assume that all of these outcomes are equally likely and say that, yeah, 3 out of the total 11. So now my question would be, what would be the correct way to get the answer? And yeah, what is the correct answer for this question? What is the probability of getting the sum greater than or equal to 10? I'll just give a minute for everyone to work and then you can share your answer. So just think about this for a minute and then you can share your answer. Let me go on to the slides. Yeah. Yeah. So who would like to share the answer? So yeah, Asma, what's your answer for this question?
Yes, sir. My answer is actually 1 by 6.
Okay, so why do you say 1 by 6?
Yeah, I say 1 by 6 because the numbers 2 and 12, each of them can only be gotten in one possible way. Like 2 can be rolled with 1 and 1 only, and 12 can be rolled with 6 and 6 only. So those each have only one possibility. And then 3 and 11 have each have two possibilities in being rolled. And 4 and 10 have each have three possibilities. 5 and 9 each have four possibilities. 6 and 8 each have five possibilities, and 7 has six possibilities.
Right.
Totally, there are 36 possibilities. And
Correct.
out of them, 10, 11, and 12, they have six possibilities totally. So I got 6 by 36, which is 1 by 6.
Yeah, nice. Yeah, that was a very good answer, and you given your reason also. Yeah, you explained your reason also very good. Right. So that would be the correct way to calculate probability. Now let me go to the question. So now imagine we are playing the same game but with three dice. Right. So the game is the same. You choose a number. I will roll three dice. If the total is your number, you will win that prize. And yeah, okay. So right now, first we will play the game where there's only one constant price. Right. So now, first question is, how many possibilities are going to be there? If you want to share your answer, just give me a thumbs up. So now I'm rolling three dice. What are all the different possibilities you can get? So I can see many of you have an answer. I would like to hear from someone who has not spoken today. So yeah, others, yeah, I'd like to please just wait. So yeah, Arav, what is your answer?
The smallest value you can get is 3, 1, 1 and 1. And the largest value is 6, 6 and 6, which is 18. So you can have values from 3 to 18.
Right. So the sum can be between 3 and 18. Now my question is, what are all the different combinations which are possible if I roll three dice? So the total is of course between 3 and 18, but what are the different combinations that can come when I roll three dice? I'll just give a minute for others to think also. Yeah, Sanjeev, Asma, yeah, I can see that you've got the answer.
So there are, sir, so in each die there will be six possibilities from 1 to 6. So because you have three of them and they're not distinct, you can have 6 cube, which is 216 total combinations.
Correct. So it is going to be 6 power 3, which will be 216 possibilities.
Yes, sir.
Right. So now let me share. Um, I'm not sure if I'm sharing the correct screen. So, yeah. So now, which total do you think is most likely to come if you are playing with three dice? Don't just give out the answer. Just think about it for 2 minutes. Then we will discuss the question. Then we'll discuss the answer for this question. Deepika, do you have a question or do you have the answer?
The answer.
Okay, right. So yeah, Deepika, what is your answer?
So probably around 11 to 15.
Okay, so I want one particular number. Which number is the most likely to come? Yeah, Madhusudan, what is your answer?
So the my answer is 10 exactly, sir. The number
Okay.
10.
Yeah, why?
So this is because as we took for the previous thing with two dice, the odds of getting 2, 12, 3, 11 are the same. So applying the same logic here, we get that 3 and 18 least possibility, 4 and 17 second least, 5 and 16 till we keep on going. We get the answer as 10, which is the most possible, most likely answer.
Oh, right. Yeah. Madhusudan, you also gave a good justification for why you got 10. Anyone has a different answer? Different answer? Okay. Asma, what's your answer?
Sir, I also got 11, 11 and 10.
Okay, so why are you saying 11 also?
It's for a similar reason as Madhusudan, like 3 and 18, 4 and 17, 5 and 16, 6 and 15, 7 and 14, 8 and 13, 9 and 12, and 10 and 11.
Okay, correct. So basically now you are pairing it together and you now feel that 10 and 11 are getting paired. So both of them are equally likely to come. So both of them are the most common, most likely totals to get, but both of them are equally likely also. Okay, so it's basically a tie between 10 and 11.
Yes.
Oh. And in your arguments, you already said that 3 and 18 are also the most least likely to come, because for 3, there's only one possible way to get 3. Similarly, for 18, only one possible way. It has to be 6 and 6, right? So now, yeah, so this question we have already answered, which is the least likely total. Okay. So now let me ask this question. Suppose, yeah, I'm sharing the correct screen, right? You're all able to see the slides. Okay, right. So now, yeah, now I'm giving the price which is proportional to the odds, and I am fixing that if you get the number 4, your price is 100, right? So now what should be the price for 14 and what should be the price for 12? I'll just leave this on for a few minutes. After that, we will, yeah, we will discuss after a couple of minutes. So just think for 2 minutes, then we will share the answer. So Prathamesh, the session ends at 4:15, right?
Ending on the 4:15. Like we have some 8 minutes, or we can stretch to 1 or 2 minutes if you wanted to.
Okay, right. Yeah, I'll mostly wind up by 4. Okay, Shivansh, Sanjeev, I can see that you have an answer. We'll just give a little bit of time for others also. Tarun, do you have the answer or do you have a question?
The answer.
Okay, yeah, Tarun, yeah, we'll just wait for others also. So just be patient for a bit.
Okay.
Okay, yeah. So Tarun, can you share your answer?
Yes. If you see, four has three possibilities, like 1, 1, 2, 1, 2, 1, and 2, 1, 1.
Okay, just give me a second. Let me write it down also so that everyone can see the board. So just give me a second. Write this down. So yeah, what are the possibilities for 4?
1, 1, 2, 1, 2, 1,
Yes,
and 2, 1, 1.
correct. So 3 possibilities out of how many possibilities?
Sorry?
So you're right. This is 3 possibilities out of the maximum or the total possibilities, which is 216. Yeah, now go ahead.
14, there are 9 possibilities.
Okay,
4, 4, 6,
okay.
4, 6, 4,
Hmm.
6, 4, 4,
Hmm.
5, 5, 4,
Okay.
5, 4, 5,
Okay.
4, 5, 5.
So basically, once you got a 554, you are now just looking at all the other combinations of those numbers. So you are able to get basically 3 other combinations.
Yes. And 2, 6, 6,
Okay.
6, 2, 6.
Then 662 also needs you.
Yes.
Okay.
Mm.
So 1,
There are
2, 4, 5, 6, 7, 8, 9. Now you have given 9 possibilities, but are there more possibilities also, or these are the only possibilities? So I can see here many hands go up. Yeah, Shivansh.
Sir, there are more possibilities like 3, 4, 3, 5, and 6.
Right. 3, 5, and 6.
So
Okay.
those permutations give you more possibilities.
So what is the total number of possibilities then?
Sir, I am getting it as 15.
1, 5.
Yes, sir.
Okay. So can you quickly tell me the other 6 which is not given by Tarun?
Sir, so 3, 5, 6 gives you 6 possibilities, like you just permute it.
Okay, fine. So I'll just do into 6 or extra into 5. Fine. Then, oh, that itself.
Yeah, that's it.
Okay, right. So now, for now, we are now able to get, yeah, we're able to get 15 possibilities for 14. Does anyone have a few more possibilities, or do you think it's only 15? Anyone thinks there are more?
Sir, me, Asma, I think there are more.
Okay.
Like, yeah, with 2, 4, and 8, we can get 6 more solutions.
But we're looking at dice, right? So maximum is only 6.
Oh, sorry. And 3, 3, and 8.
Right.
Oh,
So,
sorry. Okay, sorry. Yeah,
right. Okay. So now we have 15 possibilities for getting this total, which means 14 is, yeah, it's basically like 5 times more likely than 4. Right. So for 4, we saw it's got only 3 possibilities, but for 14, there are 15 possibilities. So if you are going to give the price of, say, rupees 100 for 4, for 14, which is much more likely, you should be giving a price which is like proportionally smaller, so you should only be giving like 1/5 of it. So yeah, for 14, you should only award a price of ₹20, right? So now it's almost 4:15, so it's time for us to stop. Before I leave, I just want to take 2 minutes to explain one particular question today, because I want you to think about this question and tomorrow we will address this question, right? So I'll just take 2 minutes from now. Let me share the screen. Okay, yeah. So what should be the price for 12? That's going to be your homework, right? So yeah, this is your homework for you to think about. Maybe I'll share the slides. Yeah, I won't be sharing the slides today. I'll share it tomorrow, including for the other session. Okay. So yeah, this question I'll skip. This is the question that I want to talk about. So imagine that two players, Anita and Balu, are playing a game of Go. Go is a traditional Korean or Japanese game. And they are playing a tournament. So it's not a single match, but they keep playing multiple matches one after the other. And in Go, there are no ties. So either Anita wins or Balu wins, and they are both equally skilled players. So now what happens is they are both putting up 5,000 rupees as stake to now get into the tournament. The tournament is now having these two people playing matches again and again, right? Whoever wins 5 matches first wins all the prize money of 10,000, right? So they just keep playing one after the other. They both have equal chances of winning the game. Whoever wins 5 games first, they will win 10,000 rupees, the whole prize money. Now they are playing they have played 6 games and the score line is 4-2. So Anita is leading by 2, Anita is 4 and Balu is 2. Now at this point, the tournament is now abruptly ended for some reason, right? So now how should Anita and Balu split the prize? If the tournament had gone fully, one of them would have definitely won 5 games and they would have taken all the 10,000. But because now the tournament is cut abruptly, how should they split the prize? So this is known as splitting the price problem, and this was the famous problem that was given to mathematicians Pascal and Fermat, right? And the way they solved this problem, that gave rise to the concept of probability and everything. So just take a minute to note down this problem, think about this problem. Tomorrow I'm going to give the answer and we will discuss around this problem, right? So I'm going to stop over here. Yeah, now I'll hand it over to the organizers. So yeah, Swasti and Prathamesh, you can take over.
Okay, thank you, sir. Flawless lecture from
सच में सच में
Yeah, thank you much for taking the
I think
session.
we should end.
Yeah, we'll have the recording.